In this lesson, we'll explore some options for finishing these complex or curved surfaces here and here. For starters, I'm going to hide the stock model so we can see our part. And let's focus on this and this surface right here. So one of these will do one toolpath and the other one will do another toolpath, just to explore some options. Now one toolpath is called waterline. And what waterline will do is it will make constant Z-level passes. So if you can imagine, let's take a look at this surface right here. It'll make a pass at a constant Z level, then adjust the Z depth and do it again and again and again, either going up or going down. Now that would be great for more of a steep area like up here, but as it gets pretty flat, a constant Z step down or step up would be very obvious right here, and you'd get what I would call stair steps or a staircase, so you'd actually see the different levels of the steps. And of course, on the more steeper walls, you wouldn't see it as much. So the waterline toolpath is not going to be that suitable for this part. And again, it would be great up here, but not so much down below. However, we have a toolpath called hybrid, which is really the best of both worlds. So it utilizes both constant scallop and waterline machining and switches between the two when needed. So if we go into hybrid, so for the machining region or machining geometry, we're going to select that surface. And we can always add avoidance later. For example, you might want to make sure you don't avoid this area here and that area up there. Now in some cases the avoidance geometry could hinder the toolpath, so another option we could do is to limit the toolpath motion based on depth. In either case, we'll keep it as is for now, and under toolpath control, we're going to choose a boundary chain and we're going to select that boundary right there. So that's really our containment boundary. And you can see how we can compensate to the center of the tool and we're containing the tool tip. For the tool, let's click a 3/8 ball, and this will be called hybrid. And for our cut parameters, we have an option here for the Z step down and the limiting angle. The Z step down defines the constant Z distance between adjacent step downs. So this is like your waterline toolpath. And the limiting angle sets the angle that defines the shallow region compared to, let's say, a steep region. So a typical angle for many cases will be 45 degrees. So we'll start with 45 degrees. And at that point, when the surface changes, it'll adjust from a waterline to a scallop toolpath. At this point, let's click OK, and we'll take a look at the toolpath, and we'll adjust as needed. So this hybrid toolpath, as you can see, we should adjust our retracts, but we have a nice clean tool motion here for the most part. So just for the sake of cleaning up the toolpath for tool motion, let's go in and change this to zigzag. And we have a pretty tight step down here and a step over for the 3D. And for now, let's keep this limiting angle to 45 and we'll click OK and recalculate. So what you'll notice here is we have our constant Z passes up here. And then down here, it's actually converted more towards a scallop toolpath. And the transition is right here. And that's that 45-degree angle mark. So with our limiting angle set to 45 degrees, you'll notice that the waterline toolpath happens up here and our scallop happens down below. And if we wanted to adjust how it comes close to this area here, we could adjust it by either adding avoidance areas or by adjusting how we're containing the toolpath. But in either case, you can see that this toolpath creates nice toolpath motion along this part. Now let's explore this area over here. And in this case, we'll do a blend toolpath. So the blend toolpath will allow us to follow these curves while also following the surface. So under the gallery here, I'm going to choose blend. And just like before, it's asking for machining region, so I'm going to select this region right here. And I'm going to say go right down to the wall and the floor. And again, for this particular example, I'm not going to choose an avoidance region so we can see the exact area that this tool covers. Under the toolpath control, let's choose this shape right here. So that'll contain it. And for the curves, we're going to choose this curve right here. Now, I'm going to choose this to partial. And if I spin the part around, just be careful, it's got a little edge there. So I'm going to make sure I grab that one up to the top. Now, right now, there's one curve. I actually need two curves. So I'm going to right click and add. And I'm going to go from here. And notice it's going the wrong way. So let's escape out of there and do it again. I'm going to add. I'm going to start right there and go up to there. So the blend part of this will blend from one curve to the next while following that surface. And for the tool, let's choose the same tool as we did last time, which was the ball. We'll call this blend. And under the cut parameters, we can modify the step over and the step over height like before, or limit the number of passes as well. For now, let's accept the defaults. Click OK, and we'll see what we get for the toolpath. So for this toolpath, you can see we get a nice toolpath that starts at the bottom and works its way up and down until it's done. And if we needed to be cautious with what was going on up here, we could have used other things such as containments or additional surfaces, or maybe this as an avoidance boundary. Another thing you can do to explore additional surface finish toolpaths is simply select all the geometry you want to machine with a finish toolpath, program it, and then copy that operation and change the toolpath. So example here, you'd go in here and you would change this to, let's just say, a scallop. And then you'd copy it and you'd change it to a raster. And you can explore the differences between those toolpaths while using the same geometry. So this gives you a few examples of the different types of toolpaths we can use for finishing. In the next lesson, we're going to create some contour toolpaths to machine these areas up here. And then we'll finish by exploring the chamfer toolpath in a separate file as well.